Okay, this is Anthony Priscilla, continuing with our discussion of binomial expansions in my college algebra class. And we're doing these expansions using Pascal's triangle. We've already gone through writing the triangle. Remember, each row of the triangle begins and ends with 1. And to get the numbers between the ones, you add the two numbers up above it. If we were going to make one more row, for instance, begins and ends with 1, 8, 28, let's see, 21 plus 25, 46, 50, 46, 28, 8, and then 1. And you use the row of the triangle. If you're going to try to expand, say, a plus b to the nth power, use the row that has n as the second number. If you look at these second numbers, 1, 2, 3, 4, 5, 6, 7, 8, the next row would have an exponent, the second number would be 9, and so forth. And these numbers, these are binomial coefficients. So just sort of looking through some of the homework, let's fly through it. A plus b to the 4th. Ooh, it's sort of hard to tell that. A plus b to the 4th. Maybe I need to zoom in a little. Let me see. Can I do that without zoom in a little? Can y'all read that better? A plus b to the 4th. We're going to use the row of the triangle that has 4 as its second number. So that's the 1, 4, 6, 4, 1 right here. I'm going to write those down. 1, 4, 6, 4, 1. And now take that first term, a, raise it to the 4th, and start decreasing the exponent. And then take the last term, b to the 4th, start at the end. And I have it written vertically. Let's see, which one is it here? It's written out horizontally. A to the 4th plus 4ab cubed plus 6a squared b squared plus 4ab cubed plus b to the 4th. For m minus n to the 5th, this next one. To expand m minus n to the 5th, we're going to use this row, the one that has 5 as the second number. So 1, 5, 10, 10, 5, 1. Let me write that. 1, 5, 10, 10, 5, 1. And you start, okay, m to the 5th, m to the 4th, m cubed, m squared, m to the 1st. Starting at the end, negative n to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st. Not much to do to simplify all of this. Like the first one, it's just m to the 5th. Well, this negative to the first power would be negative, so that's going to be a minus 5 m to the 4th n. So let's do one in this color. Here, a negative squared would be positive, so that's just going to wind up being a 10m cubed n squared. What about this one? A negative cube. What's a negative cube? Well, a negative to an odd power is always going to be negative, isn't it? So this would be a negative 10 m squared n cubed. Did y'all hear that? A negative number to an even power. I'm using the fact that a negative raised to an odd power is a negative. Ooh, can y'all read that? Let me write. A negative to an even power is positive. That looks better. Whereas a negative to an odd power is negative. So negative to an even power, positive. So we'd have a positive 5m into the fourth. And then finally negative to an odd is negative. So let's see, it's certainly not a 5m, m to the fifth minus 5m to the fourth n plus 10m cubed n squared minus, this is d, isn't it? How d has it written out? Nice horizontally. Now what about, any questions? Remember, use the row that has the exponent on the outside of the parentheses as the second number. So which one is that going to be? Let's see. On this one, number 3, the second number is a 3. So this is problem number 3. We're going to have, it's 3x plus 4y cubed. Write it bigger in case you can't. 3x plus 4y cubed. Well, we'll use 1, 3, 3, 1. Oh, let me bring it down. The triangle. 1, 3, 3, 1. This was only asking for the first and last. So the first would be the 3x to the third, and then 3, 2, 1, 3, 2, 1, and the last would be 4y to the third. So, and then it would go backwards. But since it's only asking for the first and last, what would we have there? A 27 x to the third, and now what's 4 cubed? Don't say 12. 4 times 4 times 4, that's a 64 y to the third. So first term, 3x to the third. The last term, 3x all cubed, so 27x to the third. The last term, 4y quantity cubed. So 64y to the third. Let's see. Ooh. Number 4, a minus b to the sixth. Well, we're going to use the row that has 6 as its second number. 1, 6, 15, 20, 15, 6, 1. So I've written down 1, 6, 15, 20, 15, 6, 1. And then start. Okay. A to the sixth, a to the fifth, a to the fourth, a cubed, a squared, a to the first. Be careful. That second term isn't just a b, it's negative b. To the sixth, to the fifth, to the fourth, to the third, to the second, to the first. And so this first one's just a to the sixth. And then a negative to the first power would be negative, so this is a minus 6a to the fifth b. What about this next term? Will it be negative or positive? We have a negative squared, so that's going to be positive. 15a to the fourth b squared. Well, maybe that's enough to decide on the answer, but I'll just keep going. We have a negative cubed, so that's going to be a negative 20. A cubed, b cubed. A negative to an even power is positive. A negative to an odd power is negative. A negative to an even power is positive. So let's see. a to the 6th minus 6a to the 5th b plus, looks like it's a to the 6th minus 6a to the 5th b plus 15a to the 4th b squared minus 20a cubed b cubed plus 15a squared b to the 4th minus 6ab to the 5th plus b to the 6th. Let's do this one. Number 5. Write the binomial expansion. It's a negative 3x squared minus y all to the 5th. We'll use the row that has that exponent 5 as its second number. So I think I'll write it down here. 1, 5, 10, 10, 5, 1. Then we'll use take that first term. This is going to be a little messy. That first term is a negative 3x squared. Raise it to that 5th power and start decreasing the exponent. 5, 4, 3, 2, 1. Then take that second term. Keep in mind that second term is not just y, it's negative y to the 5th, to the 4th, to the 3rd, to the 2nd, to the 1st. Now let's see, that negative 3 raised to the 5th power. If we multiplied out negative 3 to the 5th, that would give us a negative 243. And now we've done this already this semester. How did we raise one power to another? What do we do? Yes, multiply. Multiply those exponents. So the first term, negative 43, x to the 10th. Then we have a 5. What's the blue stuff? Negative 3 to an even power. That's going to be positive. Negative 3 to the 4th would be a positive 81. X to the 8th. I'm just using parentheses there for times. Negative y to the 1st is just a negative y. This is all times. So we have 5 times 81, that's a 405, times a negative 1, this would be a negative 405, x to the 8th, y. On the next one, we have a 10, we have a negative 3, x squared all cubed. Negative 3 times negative 3 times negative 3. That's going to be a negative 27. X to what power? 6th. Now, a negative y all squared would be a positive y squared. So what would that give us? A negative 270 x to the 6th y squared. It might be enough to figure out which one it is, but I'll keep going through it just for, let's see, is it enough? A negative, and then a negative. I'm thinking it's D. We have a negative 243x to the 10th, a negative 405x to the 8th y, negative 270x to the 6th y squared. So you can already figure out which one it is. Now imagine if you were filling this out. No, you can't figure it out until you're completely finished. Negative 3 squared would be a positive 9, x to the 4th. A negative number cubed would just be negative. So this would be a negative 90 x to the fourth, y to the third, which is what we're thinking it should be. And then we have a 5. Negative 3x squared to the first would just be negative 3x squared. A negative to even power, so that's a positive y to the fourth. So what are we getting there? Negative 15x squared y to the fourth. And what about the last one? Negative to an odd power, just a negative y to the fifth. And D it is. There's our answer choice, D. Any questions? Here's another one. Number 6. That'll be our last one, yeah. Okay, so number 6. Let me see. I'll cover up all those answer choices. We'll work back. Part 6. 2 plus y. Can y'all read that? It's 2 plus y over 4 to the fifth power. So we're going to use that same row. 1, 5, 10, 10, 5, 1. I'm going to raise it up a little. Sort of spreading this stuff out a lot. First term is a 2, so 2 to the fifth, to the fourth, to the third, to the second, to the first. Oh, and this is just a little mark that was on the page. It's not a fraction bar there, okay? And then y over 4. Don't let the fact that there's a fraction here scare you too much. Y over 4 to the fifth, to the fourth, to the third, to the second, to the first. Now let's start simplifying all of that. You should be able to get the answer within just a few of the strokes, but I've hidden those answers. The 2 to the fifth, 2 raised to the fifth. Maybe you can't see that. I know the glare is bad. A 32. Maybe don't put 10. I don't know why I've used the calculator on that. Y'all, I'm sure y'all could do 2 to the fifth, but that's a 32. Oh, and that's it, isn't it? Just 32. Now for the next one, we have the black 5. And what about 2 to the fourth? 2 raised to the fourth. That's a 16. I'm just trying to illustrate where the heck I'm getting these numbers, if you're wondering. So we have a 5 times 16, and then the y over 4 to the first would just be y over 4. I'm going to do a little cross-canceling here. 4 goes into 16 4 times. 5 times 4, that's going to be a 20y. Begin to see why I write it out vertically. You can look and see examples where people are working it out just all horizontally. I think it works out nicer this way. You can call this the Priscilla way. I guess you can call that for all of this. That's my last name, I guess you don't know. 2 to the third. 2 times 2 times 2, that would be an 8. And the pink stuff, we'd have a y squared over a 4 squared. 4 squared is 16. How is this going to reduce? Let's see. 8 goes into 16 2 times. 2 goes into 10 5. So are we just going to have a 5 y squared. Y'all follow that? See here, we have a 10. The 2 squared is 4. And then the y over 4 cubed. That would be a y cubed. Now don't say 64. Excuse me, don't say 16. 4 to the third. 4 times 4 times 4 is 64. You can do the cross canceling, or if you just want to wait and reduce at the end, if you just want to multiply straight across, you would have a 40 over 64 y to the third. Still got to reduce that. What could I divide both of those by? An 8. If I divided both of those by 8, would that reduce to a 5 over 8 y to the third? 20 short years will be finished. Now, really, when you're doing these, it's multiple choice again, so you can sort of figure out the answer pretty fast. But I want to go through every one of these, simplifying every one of these expressions, just because I feel like I need to do something to get paid. I have a 5. A 2 to the first is 2. And a y over 4 to the fourth. Ugh. That's going to be a y to the fourth over what? Let me plug out this little calculator again. 4 raised to the fourth power is 256. Okay, so 256. So I just want to call this. You can either do the cross canceling, but I know some of y'all don't like to do that. You just write it as 10 over 256, and well, you then got to reduce. 10 over 256, you can divide each of those by 2 to get a 5 over 128 y to the fourth. And then one thing left. Y to the fifth. 4 to the fifth is 1024. Oh, and this one, we got sort of lucky. There were no negatives in here. So all of these are positive. So let's see. The answer's going to be, let's see, 32 plus 20y plus a 5y squared plus a 5/8 y cubed plus a 5 over 128 y to the fourth plus, well, look at how I wrote this last term. Y to the fifth over 1024. The way it's written here is certainly equivalent. Put the y to the fifth out to the side and write it as 1 over 1024. So it's definitely D. Again, when you're doing this as a homework problem, you probably wouldn't want to go through and do every one. I just did that to sort of practice, just show y'all the practice on that. Okay? Let me see, was that it? Yeah, that was all the examples I wanted to do on this. So work on this binomial expansion. This is a nice, I want to say shortcut, because can you imagine on this one, if you were actually going to write these 5 out and start foiling, it'd take you a while. And the neat thing about this is that if it's multiple choice, you can decide on it after just a few tries. I did all of these, but like here, how many would it have taken? If we need 32 and a plus 20y, at that point you knew D. Okay? But just because I worked out all of these, just for illustration purposes, okay? Well, this is where we end our semester with homework, doing this binomial expansion. So I will see y'all later. Next class meeting, we'll be probably reviewing for a test. And that's it. Bye.